So this is also cross-posted in Canvas in the key page. All right. So if you go to Canvas and hit the unit keys, it's also there. Now, this should have been the numbers that you got. Now, the reason that I made you guys fill this out is this unit is all about exponential functions and logarithmic functions. Both deal with something raised to the something power. All right? It's all about exponents, essentially. So, knowing what your typical, like your perfect squares, your perfect cubes, perfect fourths, all of those will be really, really helpful. Now, do I expect you to memorize this entire chart? No. All right? What I expect you guys to know, at the very least, I expect you to know that anything raised to the first power is just itself. Anything raised to the zero power is 1. I expect you to know all your perfect squares, at least up to 10. Okay? If you can do up to 12, that's even better. Perfect cubes, you really only need to know up till 5. Same thing with 4s, just know up till 5 because those are the ones you're going to see the most. And obviously, like any of your 10s raised to whatever power, it's really easy. As long as you know that 10 squared is 100, after that, you just keep adding a 0. All right? Now, and then of course, just know your values that have a base of 2, because those are fairly straightforward as well. Now, again, I don't expect you to memorize these per se. I'm just saying that if you do, it becomes really, it's less time you have to put in the calculator. All right? But at the same time, sometimes it'll just start coming to you the more you put it in the calculator. So, for example, I can now name my perfect cubes up to like 12 cubed, I think. And it's really because in college, I did a lot with cubes. So I kept on putting cubes in my calculator, kept seeing them over and over again. They just stuck. All right. That's really the way I memorized it. I just literally just doing my classwork. All right. But the squares, especially, you guys should know your squares. All right. Now, the little note part at the bottom. So b raised to the negative n power, that's the same thing as 1 over b to the n power. So for example, if you had 2 raised to the negative 2 power, that's exactly the same thing as 1 over 2 squared, which would be 2 squared is 4, so it's be 1 over 4. Also, if you have b raised to 1 over n, meaning you have a fraction, it's basically a root of b. So for example, if you had 8 raised to the 1/3 power, that's the same thing as the cube root of 8. So whatever that denominator is, that's the type of root that you have. All right? If you see, say, 4 raised to the 1/2, that's the same thing as the square root of 4, because there's an unspoken 2 here. All right? Now, if you had, say, a number raised to, like let's say we had 5 raised to the 3/2. What that is it's the square root of 5, because it has that little 2 here. 5 is still under the radical, but this numerator of 3 becomes what the 5 is raised to. So in reality, it's the square root of 125, which is what 5 cubed is. So you need to know what these rules are because you will see them again a lot in this unit. So like I said, Unit 2 is all about exponential functions and logarithmic functions. So we'll learn about this later, but you already learned the basics of exponentials way back in Math 1. And I know you did because I taught it last year. All right? You should have. Whether you remember that or not, whatever, because we're going to go through the basics again. But you've seen exponential functions before. Logarithmic functions is new. Okay? We'll learn later that a logarithmic function is actually the inverse of an exponential function. All right? So when we get to that bridge, we'll cross it. But for right now, we're going to do some review with exponential functions. All right? Is everyone good with this? It's also cross-posting Canvas, so we'll need it. All right. So what I want you guys to do now is make sure you're logged on to Desmos, like the graphing calculator, but also log on to Delta Math and click on the assignment that says Math 3 Unit 2 Intro. We're going to do some problems together as a class. So go ahead and get that assignment open. Now, my screen's going to look a little bit different than yours, but these should be the different subcategories within that assignment, okay? Now, you may also want a sheet of paper out because we're going to do some problems together, but then the rest of it is your homework, all right? So you may want to get a sheet of paper out just to jot down some of the work that we're doing, yes? I would use paper for the ones we do together, just so you can jot down the notes. But then when you do it, you can do it if you want. Like do the notes in your journal. Yeah, if you want. I forgot some extra things. Yeah, if you want. So I'm yeah. All right, so the first one that we're going to do once you get up there, we're going to do all the ones that on my end say single. I know they don't say single on your end, but so we're going to do this very first single one, which is the very first match exponential equation in context. Okay, so the very first section that says max exponential equations in context, click on that. It should be the exact same problem for everyone, so you should see this exact problem. So you're clicking on the first section that's labeled match exponential equation in context. It's the third one down. And you should see this exact problem. It should be the same problem for everyone. Now, I would still write down what I write down on the board, but I will tell you now, I do have an app on my phone where I can snap a pic of what's on this board and it'll put it into a PDF for me. So I'll have notes for that posted. That's what these little orange things are for. It picks up where they are. All right. So if you see me take out my phone and do this, that's why. Okay. But, all right. So to review some parts of exponential functions, let's just go jump right in. So what you guys have seen with exponential functions way back when we took Math 1, which, that's so long ago, who can remember that? Exponential functions are anything where the exponent is x. All right? So your x value is in your exponent. That's how you know it's exponential. Now, what all the different features of exponential, that depends on what scenario you're given. But for this one specifically, if we read this problem, excuse me, Ella has a collection of vintage action figures that are worth $430. If the collection appreciates at a rate of 4% per year, which equation represents the value after 7 years? So typically if you see a word problem that's exponential, you're going to be using one of two formulas. You're either going to be dealing with exponential growth, which is y is equal to a times 1 plus r raised to the t power, or you're going to be dealing with a decay, which is pretty much the same thing as growth, but switch that plus with a minus. So it'll be y is equal to a times 1 minus r raised to the t power. Now, you're probably like, what the heck does all those different letters mean? Well, I'm about to tell you. So, a is your initial value. So, whatever you put in to start with. R is your rate. And typically, when you put it back into the function, the rate's typically given to you as a percent, but you want it as a decimal. All right. And then T is how much time has elapsed. Typically, it's in years. All right. So that's what all the different parts mean. Now, the hardest part with these is deciding which one to use and putting everything in its proper place. So, based off of what this says, do you think we're going to use a growth or decay function? Growth. Why? What word kind of keys us into it's going up? Appreciates. All right. That means if we put money in it, we'll get more money out of it. All right. If it was a decay, we'd be losing that money. All right. So since we're using an exponential growth, we're going to use that top formula. So before I do anything, I'm going to label what numbers go with my variables. So my A value, what's my initial value here? How much money did I start with? $430. So this would be $430. What is my rate? So how much did I grow per year? 4%. Now, how do you write 4% as a decimal? 0.04. So remember, if you move the decimal place forward 2 spaces, that would be the percent as a decimal. So this would be 0.04 or 4%. How much time is passing? 7 years. So we now have everything we need to plug it back into that growth formula. So all I'm going to do is substitute the letter with the number that we said represents that letter. So I have y is equal to 430 times 1 plus 0.04 all raised to the 7th power. And we're not doing anything else with it besides simplifying the middle parentheses. So what does the middle parentheses simplify down to? 1.04. All right. So which of these answer choices would be my answer? The second one. And that's all you have to do for those. You're just writing the equation. You're not doing anything solving wise. You're not evaluating anything. That's all you got to do. So the biggest thing you got to remember is pretty much this whole part right here. All right. You need to know what the growth equation is. You need to know what the decay equation is, and you need to know what those letters mean in context. All right. So take a minute. You can go ahead and click the answer and hit submit so you get credit for it. So if I click the second one, hit submit, should be the correct answer. Yes, ma'am.
Will it always be 1 plus or minus?
So essentially what the 1 represents is 100. Okay, because, 100% as a decimal is just 1. So we're basically saying, if we're talking about a growth, we're talking about 100% of our money plus the 4% that we're earning of that money. So with decay, it's 100% of our money minus the 4% that they're taking of our money. All right, am I good to erase? All right.
Why would it say divide 100 to find the decimal rate? Because that's right there.
Oh, because technically, you also want it as a decimal. You can always do 4 divided by 100 because it's 4 out of 100%.
Oh, okay.
So you could also do that if you forgot how to figure out the decimal. Also, Dalton Math doesn't always explain it like I do. Sometimes they take the harder route than what I do.
Yes.
All right, let's do another one. So we're now going to do the one that says table exponential functions. It's the very first one that says that. So table to exponential function. So it should look like this. Now, the generic form of an exponential function is this. Y equals A times B raised to the x power. This is what you learned back in Math 1. This is the generic form of an exponential function. Now, that is when A is your y-intercept and B is what we call our common ratio. Which essentially the common ratio is what are we, if we're looking at the table, what are we multiplying to get from one y value to the next? Because typically, if you remember geometric sequences, which is when you're multiplying by a number to get to the next number and so on and so forth, geometric sequences you can write as an exponential equation. Now, I'm going to show you two ways to do this. I'm going to show you how to do it by hand, and I'm going to show you how to do it by Desmos. Okay? So, the by hand way is to first figure out your y-intercept. Now, sometimes they give it to you, sometimes they don't. So, your y-intercept is your A value. Do they have the y-intercept in this table? You sure? As a point, how do you typically write the y-intercept? 0 and then some number, which we do have. So you're looking for where the x is 0. So right here. So our A value is the y value associated with the y-intercept of 2. Now, the common ratio, all right, we got to figure out essentially what we're multiplying between all of our y values to get to the next one. So, what would I have to multiply to 2 to get to 6? 3. What would I have to multiply to 6 to get to 18? 3. And then 18 to 54 is 3. Now, so your common ratio would be 3. So if you're multiplying the same thing over and over, that's most like your common ratio. But another way to make sure it's your common ratio is if you're adding 1 between all of your x values, that's 100% your common ratio. Okay? I'll show you what it is if you're not adding 1. That'll be a later example. But that means our b value would be 3. So if we plug it back into our starting function, y would equal y would equal 2 times 3 raised to the x power. Yep, that's exactly what you would type in. So, just without the y equals, so there we have it down here.
I used to never to leave the x as it is. Like to the power of x and it never just like to.
Nope. We're just writing the function, so x stays as it is.
So you don't have to solve it right now.
Nope. It's on the function. Now, that's the by hand way. Now let me show you the much easier Desmos way. So, in Desmos, I'm literally going to input that table that they gave us into Desmos. So I'm going to hit the plus and then the table, and I'm going to type it in. So 0, 1, 2, 3, and then 2, 6, 18, 54. Now, what we're going to do now is do a regression. All right? So, you guys remember regressions? You did them in Math 2 and Math 1. Kind of, sort of, maybe? So, regressions are essentially you're matching a function to a set of points on a table. Like you want the line of best fit, essentially. So, we're going to do an exponential regression, which you can do in Desmos. So, what you're going to type is this y1 squiggle a times b of x1. All right, you're going to type that exactly into Desmos in the next slot. So I'm going to type in y1. If you just type the 1 immediately after, it automatically does the subscript. Squiggle And the squiggle is shift, and then you hit the key below the escape button on your Chromebook. A times B raised to the x1 power. Now, make sure that log mode is clicked. All right? Because if it's not, your answer may vary differently. Now, if you look here, it gave us our parameters for this function. So it's saying A is equal to this number, B is equal to this number. Is that not exactly what we got when we did by hand? So I got A equals 2, B equals 3. Isn't that what we got when we did by hand? Yes, no? Yeah, it was. So that's the easier way to do it. If you don't remember how to do it by hand, do an exponential regression. All you got to remember is put the table in, type that in decimals. All right. And then whatever your parameters are, that's what you're going to use for A and B of your function. Yes, ma'am. Yeah. Oops, wrong thing. So I'm going to type in 2 times 3 raised to the x power. And if I hit submit, it is the correct answer. All right, any questions on that one? So your best bet is to probably just do a exponential regression. That's the easiest way to do it.
Is that the one we put in the
Decimals. So you put this into decimals after you put your table.
Do you have to always put the table in?
Yes. If you don't put the table in, it doesn't know what values to take.
What if it doesn't give you a table?
If they give you points instead of a table, you turn those points into a table.
Well, so they're always going to give you points or tables. That was my question.
They'll either give you points, a table, or something in context that you just put into the formula. All right. Everyone good with this stuff? May I erase?
All right, wait. Hold on. I'm sorry. Okay.
And remember, if you didn't get something, I am taking pictures of it, so it will be uploaded in Canvas as your notes for today. All right, our next one that we're going to do, we're going to go to where it says exponential functions basic. It's the very first one that says that. So click on that, and you should have this. All right, so we're going to the first exponential functions basic section. You should have this problem if you click on it. Now, this problem will be another exponential growth or decay. So we're using either this formula again or this formula again, depending on the scenario. All right. So let's read the problem. $7,800 is placed in an account with an annual interest rate of 6.5%. How much will be in the account after 29 years to the nearest cent? So, based off this scenario, do you think we're going to use a growth or decay? Growth. Because think about it. If you put money in your bank account automatically has some sort of interest rate. It grows. You get more money out of this. All right. So we're using the growth function. So I'm going to find my values first. So what would my A value be, or my initial value? 7,800. Good. What would my rate be as a decimal? So what's the rate first off in this percent? 6.5%. What's 6.5% as a decimal?
0.065.
Right, 0.065. You could have either divided 6.65 by 100, or you could have moved it 2 decimal places to the right. All right. Now, how much time do they want to elapse? 29 years. So we're going to take this and make our function based off of the growth. So y equals 7,800 times 1 plus 0.065, all raised to the 29th power. Now, it did not ask us to find the function. What did it ask us to do? Find how much is in the account after 29 years to the nearest cent. So literally, all we got to do is take this and put it in our calculator exactly as we see it to get a number. All right. So since I have Desmos up, I'm going to put it into Desmos. You can put it in your TI. It'll work either way. Just make sure you type it in exactly as you see it. So I have 7,800. It'll help if I clicked it. 7,800 times 1 plus 0.065, all raised to the 29th power. So this number, and I know I wrote over it, but it should be $48,443. And if we're rounding to the nearest cent, how many decimal places is that? 2. All right, so 2 decimal places. Because remember, if you have a price, your cents is always the 2 decimal places after the decimal. All right. So what would our cent value be rounded? 25 cents. So again, our answer, this would be equal to $48,443.25.
Do you put the comma when you put it in the decimal?
No. When you put in the Desmos, don't put the $sign, don't put the comma. Yeah, you have to put the decimal. So 43.25. Yeah. All right. Any questions on that one? Yes. So we're not actually solving for X or anything yet. We will later on in this unit. But for right now, if you see a problem like this, you're just plugging it into your calculator and getting an answer. All right. Am I good to erase? All right, last one that we're going to do together. So we're going to go to exponential from 2 points, the very first one that's listed. So it's the second from the bottom. So it should be this problem. So we're going to do something similar to what we did when we had our table find the function. All right. The first thing I'm going to do is convert these 2 points into a table because it just makes it easier to see. So xy 0, 13, 8, 33, 28. All right. Now again, I'm going to show you the Desmos way and I'm going to show you the by hand way. All right. So by hand, what do I need to multiply? And again, we're using y equals a times b to the x power as our reference. What value do I need to multiply to get from 13 to 3328? Just do 3328 divided by 13. 256. All right. Now, what did I add to get to 8? 8. So what this is that we need to find a number that if we multiply it 8 times, it'll give us 256. So in other words, if I had x, y, 0, 13, 1, 2, 3, 4, 5, 6, 7, 8, and we end up with 33, 28. I need a singular number that if I multiply it to all of these steps, it'll give me 3328. And if you multiply that number 8 times, it'll give you 256. So the easiest way to do that is in your calculator, do the 8th root of 256. Now, if you're using your calculator, you're going to hit math, and then you're going to scroll down to where you see a thing that says in and then this. That'll let you put that 8 in.
I don't see it. Is yours an X?
Or, yeah, it's an X. It's an X. Yeah, I can't remember if it's an X. It's an N in Desmos. So I can. Here, let me pull it up because I actually have the calculator. Oh, I'll do that later. So what you guys are going to type in. So what you guys are going to type in is in math. Then number 5 has a little X and then the square root symbol. So I'm going to hit 5. And you're going to type 8 in and then 256 underneath the radical. If you also type the 8 first and then do math 5, it'll give you that same number. It's 2. So our common ratio or b value is equal to 2. Now our a value is our y-intercept. What is that y-intercept? It's 13. So our function would be y is equal to 13 times 2 raised to the x power. Now, that is the by hand way, and that's a lot. Here's the easy Desmos way. You do.
The answer that we plug in for the, like that's where we put the answer.
So in Desmos, you would make a table again, and you'll just put in the 2 points, but within the table. And we're going to do the same thing that we did with the other table. So we're going to do a exponential regression. So y1 squiggle a times b raised to the x1 power. And look at that. Our a value has to be equal to 13. Our b value has to be equal to 2, which is exactly what we got originally. All right. So if this whole process confuses the ever-loving crap out of you, do Desmos. As long as you remember that and to put the table in, you're golden. Okay, but this part is what people forget all the time. Any questions? Okay, so the rest of the delta math is yours to do. So what we're going to do now is I'm going to give you your 5-minute break. When we come back, the rest of class time will be to work on that delta math. All right. Now, I'm also going to explain when you come back what you need to do with, because I did give you guys 2 journal entries. I'll explain where you need to put them when we come back. All right. If you did not grab your journal from the box yesterday, make sure you grab it out of the box. All right. So I'm going to set the timer for 5 minutes, and you guys can go ahead and take your break. Okay, what'd you put in exactly?
I put in the same, which is 13.
So I gave you 13 and 2 for. Okay, let me just do that. Because I'm a visual person. Oh, how you type it in? Yeah, yeah, that's why you use that. If it doesn't say why you use, you got it. It's, it does because it's painful.